Hi, here's the question for today. Check balance. Implement a function to check if a binary tree is balanced. For the purpose of this question, a balanced tree is defined to be a tree such that the height of two subtrees differ in height by no more than one. When considering this question, we could set up the condition and we could do the checking recursively. What I could, what I would do is list out all the condition of the balanced binary tree. So here's the condition: the left branch is balanced, the right branch is balanced, the height of left branch and right branch is not more than one. So this is our condition, and at the same time we could recursively calculate the height of the root branch, which is the height of the root um, is 1 plus the maximum of the left branch and right branch. Okay, so after we consider all this condition, we can consider the base case. Okay, base case is when the node is pointed to is pointing to null pointer, and we could assign it the height of this condition to 0. So when we see the when we see an null pointer, we could return -1. So that when we add 1 in our calculation, we get 0 height when we return the value. So we can construct the program here. Define a condition to check the height. And note, okay, if the height of the left branch is equal to check height, branch. We can stop the calculation. We don't need to traverse all the components of the tree because we just need to check whether the binary tree is balanced or not. So we could return a null value if the binary tree is not balanced. So in this case, we could check if left branch is null. If that's the case, we can return null. We can do the same for the right branch. If the right branch is not balanced, the check height value will return null or none in Python. So this is the first two conditions. And the third condition is to check the height of the left branch and the right branch and see if the absolute difference is less than 1. So here's the height diff is equal to ABS left height minus right height. If height diff is more than 1, it returns none. So if it's not, we recursively calculate the height, which is the max value of left height, right height plus 1. Okay, and yeah, don't forget about the base case here. If node is none, return -1. Okay, let's see if it's compiled. Oh, it's balanced. Yes, I still, because it is a helper function, I need to create a wrapper function. Is balance and take a tree as an input instead. So yeah, I can return the check height first and make sure I get the right result. Before I print out the true false statement. So it looks okay. The first tree is a balanced tree, and it returns the height of the tree, which is 1. The second tree is not a balanced tree, and it just return none. Let's create a third tree, and which is a balanced tree, and see if it's still return the correct result. Okay, note 10 left is equal to 11. Note 10 right is equal to 12. Note 11 left is equal to note 13. Right is equal to 14. Nope. 15 left is equal to, oh no, 11, 10 right, no, 12 right is 15, 12 right is equal to 16. And then tree 3, this is called a tree 3, is equal to binary tree, note 10. And then print the depth or the height of tree 3 and see if it becomes 2. Okay, so we could modify the wrapper function a bit so that it will return true or false. So if it's a balanced tree, it will return true, and if it's not a balanced tree, it will return false.